In this video, we will practice simplifying trig expressions such as these. Now, as we do that, I need you to keep in mind these Pythagorean identities. You should either have these memorized or you should be able to generate a chart like this within about a minute. Alright, let's go ahead and do problem number 1. Most often, all you need to do is rewrite the expression in terms of sine and cosine. For example, tangent is sine over cosine, so this is sine x over cosine x. Cosecant is the reciprocal of sine, so this is 1 over sine x. Now I notice that I have a sine in the numerator and denominator, so those can cancel out. That leaves me with 1 over cosine x, which is secant x. Never leave it as a fraction if you can just write it as a non-fraction. Okay, let's take a look at number 4. Alright, let's try our initial strategy of writing everything in terms of sine and cosine. Cotangent is cosine over sine, so that would make this cosine beta over sine beta times cosine beta over 1, I'll just say, plus sine beta over 1. So far that gives me cosine squared beta over sine beta plus sine beta over 1. Now, if I want to add these, I'm going to need like denominators. So this would have to be multiplied by sine beta in the numerator and the denominator. Okay, now I have like denominators. This is sine squared beta. So now I have cosine squared beta plus sine squared beta over sine beta. Now it's time for one of those identities. The main Pythagorean identity is that sine squared theta plus cosine squared theta equals 1. So that's just absolutely jumping out at us. So that tells us that we are looking at 1 over sine beta, which of course is cosecant beta. So don't leave it as a fraction if you can write it as a non-fraction. So that should be your answer to number 4. Okay. Now we're changing gears slightly. Instead of just simplifying, we are proving that two expressions are equal to one another. So the important thing to remember is you can only work on one side of the equation or the other. You cannot change sides. So I always pick the more complex side, so I'm going to start on the left side now. So cosecant is 1 over sine. So that's my numerator. I'm going to just switch colors to make it more obvious. So cotangent is cosine over sine. So this is going to be cosine over sine. Okay, and I'm going to just work this and keep going, and hopefully it will equal secant when I'm done. Alright, now, when you have a fraction divided by a fraction, you multiply by the reciprocal. So what I have is 1 over sine x times, and I'm going to do the reciprocal here, so this would be sine x over cosine x. Now I'm noticing that I have a sign in the top and the bottom, so those will cancel. And so now I have 1 over cosine x, which is secant x. And that's exactly what we were trying to prove. Secant x is equal to secant x. So here we have verified the identity. Alright, let's take a look at number 5. I'm definitely going to work the left-hand side because that looks more complicated. In the numerator here, I see secant squared minus 1. Let's check the chart of memorization. Secant squared minus 1 is equal to tangent squared. So let's go. So I should be able to make that a substitution and say tangent squared x. Okay. Oh, and here I'm going to go ahead and start color coordinating. So down here I have secant squared x. And I'm just going to keep going, and hopefully it'll equal sine squared x in the end. Alright, so I am going to rewrite everything in terms of sine and cosine now. So tangent is sine over cosine. So my numerator will become, and this is squared. So sine squared x over cosine squared x. That came from the tangent. Okay, now secant is 1 over cosine. So 1 over cosine squared x. Okay, now when you divide a fraction by another fraction, you multiply by the reciprocal. Alright, so the blue fraction here, I'm just going to write that down. So I have sine squared x over cosine squared x times. Alright, now I'm going to multiply by the reciprocal. Okay, so the reciprocal of this is going to be cosine squared x over 1. Now I'm noticing that the cosine squared x will cancel each other out, and all that's left is sine squared x. And that's exactly what we wanted, so sine squared x is equal to sine squared x, and here we have verified the identity. Okay, let's find number 7. Hopefully it will keep being that easy. Alright, so here again, the first thing I'm going to do is rewrite everything in terms of sine and cosine. So secant is 1 over cosine. Tangent is sine over cosine. And then, so I'll just write sine x as sine x over 1. Alright, hopefully when all the dust clears, this will equal 1 over secant x. So what can I do? What can I do? Well, multiplying these together, I have 1 over cosine x minus sine squared x over cosine x. Alright, well, no work here. I already have a like denominator, so I can add these together. So that'll give me 1 minus sine squared x over cosine x. I think that's on my identity chart of memorization. 1 minus sine squared x. Let's check it out. Alright, yes, 1 minus sine squared theta is equal to cosine squared theta. Okay, so I should be able to substitute this numerator for cosine squared x. So now I have cosine squared x over cosine x. Okay, now these, the cosine in the denominator will cancel out one of the cosines in the numerator, and that will just leave cosine x. Okay. Alright, now we're really done, and you just don't realize it because we remember that secant equals 1 over cosine. So swapping these, then you realize that cosine is equal to 1 over secant. Alright, it's really a two-way street. So that's what's happening right here. We have cosine, but cosine is the reciprocal of secant. So cosine is equal to 1 over secant, and that's exactly what we were trying to prove. So 1 over secant equals 1 over secant, and we're done. We've done it. Alright, let's take a look at problem number 8. Okay, my goodness. Let's go ahead and rewrite everything in terms of sine and cosine and just sort of see what happens. Cosecant is the reciprocal of sine. So this will be 1 over sine squared. And then tangent is sine over cosine. So sine squared x over cosine squared x. And then minus 1. Alright, hopefully when all the dust clears, it'll equal tangent squared x. Now, sine squared and sine squared right now will cancel each other out. So right now I have 1 over cosine squared x minus 1. Well, this is the reciprocal of cosine, so that is secant. So secant squared x minus 1 is what I have now. Now that looks like something that's going to be on the identity chart of memorization. Let's check it out. Secant squared minus 1 is tangent squared. So there you go. Tangent squared x equals. I'll just drop this down. And there we've done it. Once again, we've proven the identity. Alright, let's keep going. Number 9. Okay, again, I'm going to work the left side. And in fact, in general, if I see a minus or a plus, that's the side I pick. I'm going to start with a standard move of writing everything in terms of sine and cosine. So cosecant is 1 over sine. So I have that. And I'm just going to write this as sine over 1. Now, like denominators, that's what it would take to be able to put these together. So if I want to have like denominators, I'm going to need sine x. That's only going to be legal if I multiply the numerator by sine x as well. So now I have 1 over sine x minus sine squared x over sine x. With my like denominators, I can now put these together, and it becomes 1 minus sine squared x over sine x. That looks like something off of my chart of identities that I've memorized. 1 minus sine squared is cosine squared. So I can go ahead and make that substitution and say cosine squared x over sine x equals. Alright, now I don't have sine squared, so I can't say cotangent squared. But what I can do is I can split this up. So cosine squared is the same thing as cosine x times cosine x. And so now I've got sine. So, let me pay attention of what I'm heading towards. I'm shooting to have cotangent times cosine. So I'm going to purposefully write the sine x underneath the cosine, just to make it more obvious that what I have now is, in fact, cotangent. Alright, because this part over here will make cotangent x. And then I'll just bring down the cosine x. And that's exactly what I was trying to get. So I have verified the identity. Okay, another one down. Okay, let's take a look at number 10. Okay, this one looks a little bit challenging. I'm definitely going to do the left-hand side. And I see 1 plus sine x, and I see 1 minus sine x. And here's what that's reminding me of. This part of the chart right here. 1 plus sine x, 1 minus sine x. If you multiply those together, you get cosine squared. Okay, so I need like denominators anyway, so my strategy is going to be, let's go ahead and multiply this side by 1 minus sine x. Alright, of course I'd have to do that in the numerator as well. And let's multiply this side by 1 plus sine x. Okay, so now I have 1 minus x times 1 plus sine x. I have both of those. My denominators are the same now. I have like denominators. So I'm just going to recopy everything. So here's what I have. So my like denominator is 1 minus sine x times 1 plus sine x. Okay, that's what I have in both denominators. Now I'm going to combine the numerators, alright, because I'm adding this into one big fraction. For a moment here, I'm going to just keep this like it is. So 1 minus sine x cosine x plus cosine x 1 plus sine x. Alright, that's what I have right now. So now I'm going to do two things really at once. One thing I'm going to do is this substitution right here. 1 plus sine x times 1 minus sine x, that's cosine squared. So I'm going to make that substitution. So my denominator, my new denominator, is going to now be cosine squared. Now the other thing I'm going to do is I'm going to do the distributive property. So if I distribute the cosine x, that's going to give me cosine x minus sine x cosine x. And then if I do the same thing over here, that's going to be plus cosine x plus sine x cosine x. Alright, so here's something interesting. I have minus sine x cosine x, and I have plus sine x cosine x. Those are opposites. So if I combine those like terms, they just cancel each other out right now. Alright, one's positive, one's negative, they're gone. That leaves me with cosine x plus cosine x. So that is going to be 2 cosine x. So now in the numerator, I have 2 cosine x over cosine squared x. Okay, and just to make it obvious what's happening, cosine squared, of course, is cosine x cosine x, right? That's my cosine squared. I just wrote it that way to make it obvious that these are just going to cancel each other out, of course. So that's going to equal 2 times, well, you know, it's 2 over cosine x, which is the same thing as 2 times 1 over cosine. You know, they're different. And that's the same thing as 2 times secant, because 1 over cosine is secant. And that is exactly what I was trying to prove. Alright, that equals 2 secant x. And once again, we have proven the identity.